All right, guys, good morning. Good afternoon if you're watching in the afternoon. If you remember from yesterday's lesson, we took some time to talk about those three pieces of DNA. They make up what we call the nucleotide. And so we talked about the sugar and the phosphate being the backbone of our DNA strand. And if you notice the DNA strands here, you can see the sugars and the phosphates alternating. But we also talked for a second about what we call the nitrogen base. Well, if the word nitrogen is in it, it's probably because nitrogen makes up those molecular structures. And so we're going to spend some time today talking about our four nitrogen bases that make up DNA. And as you see here, they all end in INE. Now, there's a little special change that's going to occur when we get to RNA, and we'll talk about that a little later because we'll change out one of these bases. But for now, we're going to talk about adenine, guanine, thymine, and cytosine. And so I want to show you a little something about these four bases before we start working on how they pair together. And that is these two special terms, purines and pyrimidines. These two bases, adenine and guanine, fall under the category of being a purine. And I'm going to show you what that looks like here. Purines are a very special molecule that has a double ring structure. And if you take a look at these, you'll notice that they're made of nitrogen and hydrogen bonds, okay? And so these molecules have that double ring structure, whereas your pyrimidines have a single ring structure. And so when the base pairing occurs, these bases are going to pair with each other, one purine and one pyrimidine. And so let's look at that real quickly here. We always pair adenine with thymine, and we always pair guanine with cytosine. And so I'm going to show you that now. Adenine always pairs with thymine, and guanine always pairs with cytosine. There's a really cool phrase for you to remember. Apples in the tree, car in the garage. If you can remember that, it can help you with that base pairing. Ms. Townsend's going to show us now how that base pairing works on a strand of DNA.
Okay, so we have our two backbones, our sugars, our phosphates, and then in the middle we have our nitrogen bases. Okay, so like we just talked about, cytosine is always going to bind with guanine, so they should kind of fit like a puzzle. Okay, these bond by hydrogen bonds. So again, if we have guanine, it's going to bind with cytosine. If we have thymine, it binds with adenine. And then again, adenine will bind with thymine.
Okay. And of course, if we start taking a look at how all of these nitrogen bases bond together, you'll notice that they make up a special code. We're going to talk a little bit later about that code, what that code means. Remember what the rule is about your DNA. It is the instruction manual for everything about you as an organism. And so that instruction manual has to have codes or has to have some kind of writing somewhere. And we're actually going to show you now, we're going to pretend for a minute that that DNA strand stands for something special.
Okay, so if we took a section of this DNA, this would code for a specific trait. Okay, so for example, if we were talking about hand clasping, so whenever you clasp your hands together, your dominant hand, is that right?
Dominant hand
yes, should always be
the dominant trait for that. Yeah.
Okay, sorry, thank you.
We're all trying to do this together. The dominant trait says that your left hand would clasp, or your left thumb would clasp on top. And so if we all did that now, we'd have to turn the face this way. And Mr. Merrick's going to join us. And if we clasp, we may need to come down a bit. My left thumb is on top.
My left thumb is on top.
And it's my right thumb that's on top.
And so when we start looking at coding for traits, that means Mr. Merrick happens to have the recessive trait. And then we can also do.
Okay, another one would be the rolling of your tongue. Okay.
Which is dominant. Yes, rolling of tongue is dominant, and not being able to roll your tongue is recessive. So you'd be surprised how many people can actually do this. So let's try.
I can't do it. I can't.
That looked really funny.
Yeah.
And so when we look at our strands of DNA, when we look at those genetic codes, those are the types of things they code for. They code for all the traits that make us who we are. The reason why I'm this tall, Miss Townsend is that tall. Why we have different hair colors, different eye colors, different shapes of everything about us. Ears, hairlines, everything. Just to maybe mention one more time, do not forget my little phrase, apples in the tree, cars in the garage. That's very, very helpful. You might want to write that down. And remember that those nitrogen bases are what are going to pair together to give us that genetic code. Okay? And we have some practice for you to do today. We have some more practice for you to do tomorrow. Get really comfortable with base pairing. It's just like reading a code in a code book. We'll see you guys soon.